Hello and welcome to my final project presentation for my information security class. This presentation will be based mostly around cryptography and some of the facets of it, including encryption and encoding and private key infrastructure, or at least touching on private key infrastructure. So getting right into it, while cryptography may seem like a new field as technologies such as encryption take center stage in information security, cryptography has actually been around for thousands of years. That form of cryptography, however, was mostly used by organizations and governments to keep secret messages away from prying eyes, while the encryption that we use today is meant to keep hackers and other intruders away from our files and other data on a much larger scale. All the while, though, the core function of cryptography has been meant to keep our private information away from prying eyes. Moving right into one of the simple methods of encryption, we find the rotten encryption algorithm. Rotten spelled as ROT-N. And so in this form of encryption, every character is rotated through the alphabet a certain number of times. So for instance, a ROT2 letter A would then become a letter C after the encryption has taken place. This encryption method is one that can be easily used on text, but should not be used if you're trying to keep your information private from anyone outside of an ordinary user. For instances in where you'd be keeping data private from a power user or any other intruder, a hash would be much more suitable. Getting right into hashes are different algorithms that you can use to produce some sort of outcome. In the world of computers and information security, hashes are used to create an output that is a fixed length number. These values that are output by the hash are essentially unique keys that represent what it was used on. So if you were to encrypt a text file using an SHA hash, the hash value that you would get for that text file would be a representation of that text file rather than the text file itself. Once a hash function is used on a file, however, that file will now not be recoverable unless you have the key for that specific hash. These hash functions are useful for securing you or your company's data against more experienced users. Going back to the rotten encryption algorithm, while it may be titled as an encryption algorithm, it is actually an encoding scheme. Encoding schemes are different from hash algorithms in the way that they can be decoded. While hash algorithms are very hard to break and requires many resources, encoders are light enough to have a simple enough algorithm to be able to decode in an instant. There are many encoders out there such as base64, Unicode, HTML encoding, and URL encoding that can be used to accomplish many different tasks. For example, when putting a special character into HTML code, that special character will be broken down into a certain format that can be read by any web browser. Once the web browser is able to read the HTML code, it will know to display that special character rather than the code itself. While encoding can be useful for situations such as this, it is important to note that none of these encoders mentioned should be used for actual file encryption. Now that we've gone over some methods for encrypting your data, the next most important step is choosing the method to keep the keys to your encryption safe. While this may seem a bit obvious, failing to use methods to protect your encryption keys will make you encrypting your data utterly useless, as the level of privacy that you can get from this technology will rely solely on the strength of both your algorithm and the key. Moving on, there are two main methods for creating encryption keys, one being symmetric encryption and the other being asymmetric encryption. With symmetric encryption, you have one encryption key that can be used to both encrypt and decrypt the data. This method presents us with a lightweight and easy way to encrypt data and share data with people that you want to have access to it as well. This method presents us with a lightweight and easy way to encrypt data and share that data with the people that you want to have access to it as well via the sharing of that one key. However, the problem with symmetric encryption is that since it uses the password to encrypt and decrypt for everyone who has it, it is easy for an intruder to determine the key and use it to view that data that you have been trying to keep private in the first place. This makes symmetric encryption types unsuitable for major businesses that need to protect customer information versus you keeping maybe some of your personal files like your taxes and returns and things such as those on your personal home storage network. Moving on to asymmetric encryption, it is used in a lot of different protocols such as RSA. And with this encryption protocol, you have two different keys. So these two sets of keys are referred to as a public and a private key. Having these two keys will make sharing and transferring data publicly much safer because the encrypted message that you send to the other person will require their private key in order to decrypt the message. Meaning that even if your public keys have been stolen, as long as you have your private keys, whoever is stealing this message will not be able to open it without your private key. For example, imagine there are two people, person A and person B. Now let's say that they both declared a public key, yet kept another private key from even each other. That way it is truly private and is only left to them. This private key will allow either party to decrypt a message that has been encrypted with the other party's public key. Moving back to the example, if person A wants to send an encrypted message to person B, they will need to encrypt the message first by using person B's public key and then sending that message. And then once person B has received that message, they can then decrypt it using their own key that they have. This is a very rudimentary and simplified explanation of an asymmetric encryption protocol, but this does go on to show how it is important for you to decide upon a protocol to use to keep the keys to your encrypted data safe from prying eyes just as much as you would keep the data itself. So in conclusion, cryptography, just as much as any other technology, is growing in complexity, mostly due to the increased need for it as well in our modern infrastructure. In the modern world where information about you and me is being broadcast nearly all day, every day, it is important that we stay on top of that information, keeping it private and only to be seen by the people who are meant to see it. I hope you guys enjoyed this short and very simplified introduction into the world or field of cryptography, and thank you for watching.